Morning, everybody. All right, good morning, everybody. So I'm going to get started. All right, so today's lecture is basically, I think it's the last one where I have to transition you from C to Java. And then after this, it's going to be all straightforward Java. So it'll be stuff you haven't seen yet in your C course. Mostly it'll be about using and creating objects after this lecture. But today I want to cover arrays. And while we're doing arrays, we might as well do loops. Okay, so the good news is for you is that arrays in C are pretty similar to the way that arrays work in Java. But Java arrays are easier to use and they're safer to use. So all that stuff you had to worry about in C about whether or not you had to dynamically allocate an array or not, you don't have to worry about that in Java. Now, they are somewhat uncommon in Java because the Java standard library provides much more functionality than the C standard library. So in the Java standard library, you have all sorts of data structures already built into the language. So if you wanted something like a resizable list, it's already there for you in the library, right? You don't have to do it yourself, right? In C, if you wanted a resizable array, well, there are no resizable arrays. So now you have to deal with reallocating the array and so on and so forth. Right? So all that's, arrays in Java, they're there, but they're somewhat uncommon. So just like in C, an array in Java holds a fixed number of elements, right? And the elements all have the same type. And just like in in C, the length of an array is established when you make the array, right? So pretty much the same as in C. So one of the differences you'll see in Java is that Java programmers tend to not name the array. The type of the array looks different than the type of the array in C, right? So in C, the square brackets go after the array name, right? So you would write double collection square bracket in C, right? Most Java programmers put the square brackets after the type, after the element type, right? To most Java programmers, that looks like an array of double, right? To a C programmer, that looks like a syntax error. You can, if you want to, put the square brackets after the array name. So if you want to stick with the old C notation, that still works in Java. I'm always going to write it the Java way, but if you want to, you can put them after the variable name. Right. So that thing there says that collection is a variable whose type is an array. There's no array yet, right? So there's no actual array yet. It's just there's a variable that can hold an array. Right? So in C, you can initialize an array, right, using braces. Right? So if you make an array in C, oh wait, that's an error. Those square brackets go after the T, right? You can write equals and then braces and then some sequence of characters. So in this case, some sequence of elements in between the braces, right? And that makes an array. In this case, in C, T will be an array of car of size 4. Right? In C, you cannot reassign to an array, right? So again, square brackets are in the wrong place. They should be after the U, right? So if you make an array variable, you cannot assign to an array variable after, except at initialization, right? So that's initialization, declare the array, and give it some values at the same time. This is assignment, right? Declare the array, and then somewhere else try to assign some elements to the array. You can't do that in C. Right, that never works. Right, you can never assign to an array variable in C. What am I doing here in C? Right, that's C. Okay. What do I want to say here? Okay, so that's all right. So in Java, so the best way to think about arrays in Java is that they are dynamically allocated arrays. So unlike in C, where you can have either a dynamically allocated array or you can have a local array, right? So all the examples I've been showing you so far in C, they're all local arrays. Oh, I guess I should go here, right? And so there's an example of a function in C, right, that tries to return an array of double, right? So inside the function, you make a little array, right? You set its elements to 1, 2, and 3, and then you return x, right? So that compiles cleanly in C. But when you run it, it barfs, right? You all know that, right? Yes? You all remember that from your C course? I'm not seeing a lot of yeses. Right? That barfs in C, right? So this compiles, but it doesn't run properly, right? When you try to run it, if you're very unlucky, it appears to do the correct thing. Most of the time, though, it's going to cause some sort of error to occur. You'll get a segmentation fault, or you'll get some bizarre output, or the elements won't be 1, 2, 3, or something strange will happen, right? When you write that in C, the lifetime of X is the block in which it's declared in, right? That's a local array, right? So X only exists from that point there to that point there, right? After the function returns, X no longer exists, right? The memory for X is considered to be invalid, and so it goes away. So you can't do it this way, right? If you want to return an array from a function in C, you have to dynamically allocate the array, right? So in other words, you have to do double star X equals malloc 3, 3 times size of int, right? And then you have to do your X equals 1, x1 equals 2, and x2 equals 3, right? And now you can return X and everything's fine, right? So that's what you have to do to correctly return an array in C. Fortunately, in Java, you don't have to worry about that. But what you should remember is that Java arrays are essentially dynamically allocated arrays in C, right? So instead of using malloc to allocate the array, you use the word new, right there, right? So here, collection is a variable that can hold an array of doubles. No array yet, right? So there is no array here. So if you try to set collection 0 to something, the compiler will complain. So this actually fails at compilation time, I think. Yeah, it fails. It's an error. So you don't have an array yet. To create the array, you use new, right? So you write new, and then for an array in Java, you write the element type. So this makes an array of double, right? And then you put in how long you want the array to be, right? So you can use any number from 0 up, right? So any non-negative number, which is also different than C, right? There are no zero-length arrays in C, right? So that makes an array of 10 doubles, right? Now, if you, back to my C example, where to go? Here, right? So if you don't assign the elements here, right, after you calling malloc, right? So if I don't do that, sorry, and I don't do that, and I don't do that, right? You still have an array of size 3. More precisely, you have a chunk of memory that can hold 3 ints, right? But the memory is not initialized to anything, right? So the elements 0, x0, x1, and x2, they could have any value at this point, right? And so when you return the array back to the caller doesn't, all they know is that they're going to get back an array of size 3 if you document your function correctly, right? Otherwise, you have no idea what's there, right? So the memory is uninitialized in C. And that's not true in Java, right? So in Java, memory is always initialized for you, right? So here, I'm going to make an array of Boolean, so 3 Boolean values, right? 4 int values, 5 double values, right? In all 3 examples, you have arrays, and the elements of the arrays are initialized to some value, right? So let's just run this and see what happens. And I'll explain how to print out the array in just a second. Where's Eclipse? I have too many applications open. Here we go. Right, so there's the exact same code, right? When I run it, right, you get false, 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 right? So Boolean arrays, the elements are initialized to false. All of the numeric arrays, the values are all initialized to 0. So for the ints, you get 4 zeros, and for the double array, you get 5 0.0s. Right? Now, to print the array, you unfortunately have to write, it's a little bit cumbersome, right? So if I just print out some bools, like that, right? The compiler is perfectly happy with that code. So you can pass whatever you want to print to system.out.print or println, right? And it'll work. Unfortunately, if you do that for an array, you get some bizarro output, right? You get something strange. It'll look like that. It'll look different on your computer. It might look different every time you run it, but it looks something like that, right? And so what it's printing out here is some sort of encoding of the location in memory of where that array lives, which is not useful to us, right? I mean, that doesn't mean anything to you if you're running your program, right? So if you want to print the array, you can either write a loop and print out the elements of the array yourself, which is tedious, but that's how you'd have to do it in C, right? In Java, so what you do is you call a method to do the work for you, right? So there's a method in the class called arrays. You can see it's imported up here, right? So in the package java.util, there is a class called big A arrays with an S, right? If you ever see a pluralized class name in Java, it's probably indicating to you that it's a bunch of methods that operate on, in this case, an array, right? You'll also see something called collections with a big S, with an S at the end. That's a set of methods, a set of methods that operate on these things called collections in Java, right? There's other things as well, right? So the methods in arrays, they all operate on arrays, right? Inside that class, there's a method called toString, right? So toString will take an array of whatever element type you want, right? And it will produce a string representation of the array that looks like this. Oops, sorry, that looks like that. That looks like, sorry, that looks like that. Okay, so you get square brackets on either end of the array. You get each element printed out individually with a comma in between, right? And a space, comma space in between, separating all the elements, right? So printing out an array is much easier in Java than it is in C, right? It's still a little bit cumbersome to write, right? It would be nice if you could just write system.out.println some bools, but you can't. Okay, so there are the default values for arrays of primitive type, right? So all of the primitive types, it's either 0 or false. It's easy to remember, right? Now the question is what happens if you have a reference type, right? So what if we do an array of strings? So string, because that's the only reference type that we know of so far. Some strings. So it's the exact same syntax. I'll make an array of size 1. Right? It's the exact same syntax, right? Element type here, square bracket, new, element type there, right? Number of elements that you want in the array, right? Is it initialized? So the answer is yes, it is initialized. Some strings. So they are initialized, but the value that they get initialized to is null. Right? Now remember I told you there's no pointers in Java, right? So so there's no pointers in Java, but that looks an awful lot like a null pointer, right? And so that is in fact almost exactly what it is, right? It's actually a null reference. So if you make an array of reference type, where the elements are of reference type, sorry, the array gets initialized, all the elements get set to the value null, which means no object or no reference, right? So you have an array, in this case of size 1, right? There are elements in the array, but you can't use them for anything, right? They're all null. So you have to now go in and set the individual elements to the actual string objects that you want, right? So in other words, if I try to use the first element of the array to do something, right? So what do I want to do with the string? So I want to turn it to uppercase, right? I should have picked a shorter variable name, but anyway. So to make a string into uppercase, you just call its toUpperCase method like that, right? So some string 0, that is a string reference, right? That's the first element of the array, and I know that I have at least one element in that array, right? To ask that string reference to convert the string to uppercase, you call the toUpperCase method, right? So if you try to do that, right, now your program barfs, right? You get what's called an exception in Java, right? So you see here, exception, right? An exception indicates an exceptional event, usually an error, has occurred in your program, right? It complains, it says that I can't call toUpperCase because some string 0 is null. Right? There is no string object on which to call toUpperCase. Right? So just like in C with a null pointer, you can't use a null reference for anything. You can print it out though. So if you try to print it out, you do in fact get the word null. Right? There's really nothing else you can do with it. Right? If you ever see something called a null pointer exception in Java, it's indicating to you that you tried to use a reference that has no object. Okay, so if you have an existing array and you want to fill it with some values, all the same value, there's a method in arrays called fill. Right? So here I make an array of 10 doubles. Right? If you print it out, they're all zeros. Right? If I want to set them all to 1, I can just fill the array with the value 1. Right? So you call fill. Yeah, you import, right? So don't forget to import. You have to import arrays to use it. Right? So arrays, fill, and then some doubles, and then 1.0. Right? And then when you print out the array again, you got an array of 10 ones. Right? So fill is sometimes handy. It's not that handy, actually, but it's sometimes handy. Right? Usually if you create an array, you either want all the elements to be 0, or you want them to be different values. Right? It's somewhat unusual to fill an array with all the same value that's not 0, if it's primitive type. Right? I guess you might create a Boolean variable, a Boolean array, and then want to set everything to true. So I guess it would be useful there. Right? The length of an array. C doesn't keep track of the length of an array. Right? That's the crazy thing about C arrays. Right? If you make an array in C, you have no idea how big the array is. You have to remember how big it is. Right? Java arrays remember how big they are. Right? So when I make an array of size 10, I can always ask the array, hey, how big are you? Right? So you put in the array name, and then you write dot length, and that returns the number of elements in the array. Right? So n in this case will be 10. Right? It will always be 10 in this case. Right? So you can always ask for the length of the array. It's not a method, right? So there's no round brackets here, right? So it's just dot length, right? And that gives you the number of elements in the array. Right? So that's another big advantage of Java arrays over C arrays. I think you know all this, right? So the elements of an array, the values in the array are called elements, right? Just like in C, they are zero-based indexes, right? No negative indexes are allowed, right? So if you have an array of length 10, then the last valid index is 10 minus 1, right? So you can use the indexes 0 through 9, right? The last valid index you know in Java, right? You can always ask the array, what is the last valid index, right? It's always the length of the array minus 1. Using the array is exactly the same as using the array in C, right? Square brackets, index of the element that you want to use. Either you want to set or you want to get the value of, right? So I can set the first element, right, by writing in square bracket 0 and then equals something. I can get the first element by writing square bracket 0. If you try to use an index that's out of bounds for the array, right, in C, you have no idea what will happen, right? It's undefined behavior, right? Usually something happens, but your program doesn't crash. You end up with the wrong result, right? If you're lucky, your program crashes when it goes beyond the end of the array. Right? In Java, your program always crashes when you go past the end of the array. Right? So you always get what's called an array index out of bounds exception. So back here, let me get rid of this line here. Right? And so we'll try to use, well, let's use some doubles. Right? So some doubles 10. Oh, wait, 5. Okay, so some doubles 5. Like that. So it's not a compilation error, right? But at runtime, your program automatically crashes, right? You get a somewhat useful message as well, right? Index 5 is out of bounds for length 5. Right? So your program always crashes if you try to use an invalid index, right? Which is another, I guess, advantage of Java over C, right? In C, it's undefined behavior. In Java, it's guaranteed behavior, right? You're guaranteed to get an exception. What else? I was going to say something else. Oh, it escapes me now. Okay. Oh, here. So unlike in C, attempting to access an element using an invalid index always results in an error, and it's immediate, right? As soon as that line of code runs, it throws an exception. Oh, now I remember. So there is a price you pay for throwing the exception, though. Right? Every access to the array is checked in Java. right? That means every time you try to access an element in the array, there's an if statement running, right? Is this index valid? If it's not, throw an exception, right? In C, you never pay that price unless you actually write the if statement, right? And so that's the difference between the two languages, right? Just accessing an array in Java is slower than accessing an array in C, right? Because the access is always checked, right? So an error in Java is usually indicated by something called an exception, right? An exception is just an object, right? So exceptions are classes. When you get an exception, some exception object is created, right? And then the runtime, so the Java virtual machine now deals with this exception object that was created, right? Often the exception object carries information with it regarding what happened, right? So when you index, when you use an invalid index, the exception object carries information about the index that you used and the size of the array, right? So in Java, when you get an exception, the program stops running immediately at the point where the exception was occurred, right? It's possible, although I don't know if I ever show you how to do this, it is possible for the programmer to now intercept that exception, right? So in Java, the phrase is you can catch the exception. And now you can try to deal with that exception object yourself if you are able to, right? So that's called an exception handler. This says more on this later in the course, but I'm not convinced that's true, right? If the exception handler is not found, then the program stops running, right? So the program will crash, which is usually what you want to happen for things like indexing an array out of bounds, right? If you're trying to access something that's not in the array, that's a programming error of some kind, right? You want to know right away that that's a problem, right? You don't want to be in the situation in C where your program keeps on running and then sometime later something bad happens, right? Okay, so loops, right? If you have an array, you almost certainly want to do something with the elements of the array. You're going to want to write a loop, right? So in C, if you want to find the maximum element in an array, right, you pass in the array, right? You pass in the size of the array, right? Now you loop over the array looking for the largest element in the array, right? In C, there are no zero-sized arrays, right? So it would be unusual for someone to try to call this function passing in 0. But it could happen, especially if the size is computed with some computation, right? So if you get a size of 0, there is no maximum element. And so now the question is what on earth are you returning for the value? Right? You're returning a double, right? There is no double value well, that's not true. There's it's not obvious what the double value is that you want to return if your array has size 0, right? You want to return something here to indicate that an error has occurred or that the element is not existing, right? And it's not exactly obvious what value you would return here, right? So I'm going to leave that as a question mark, right? Now to find the smallest, largest element, right, you just loop over the elements of the array, right? So you start by assuming the largest element is the first element, starting at index 1, because you don't have to look at index 0 anymore, right? So starting at index 1, going up to but not including the size, right? Adding 1 each time to I, right? Just look at array element I and compare it to the current largest value, right? If the array element is bigger than the current largest value, well, you found a new maximum value, right? And at the end, return I, right? Okay, so C supports the exact same type of loop that I just showed you there, right? So the code's exactly the same, almost. Right here, you don't have to pass in the size of the array, right? The array knows how big it is, right? If the length is 0, you can do something about it. You can throw an exception to indicate that an error has occurred, right? And so if you want to, in Java, if you want to indicate to the caller of the method that something unusual has occurred, you can always create and throw an exception object, right? And so the way you do that is you say throw, right? You make your exception object, so you use the keyword new to make an object, right? And now you pick one of many different types of exceptions that you can throw in Java, right? There's literally dozens of them that you can choose from, and you can make your own, right? So the most common one that you will use in this course anyway to indicate that someone has passed in an incorrect value is this thing called illegal argument exception, right? When you create your illegal argument exception object, there's always a round bracket and a round bracket, right? So it looks like a function call. It's not a function call. It's calling something else that I'll tell you about later in the course, right? If you want to, you don't have to, but if you want to, you can put in a message here to indicate something about the exception, right? So here I'm putting in the message array length equals 0. You could just leave it blank and not put in anything, right? When the exception gets thrown, this message will get printed. Right? Okay, so in Java, you can actually deal with invalid inputs in a nice and a nice unified way, right? In C, there are at least 4 or 5 different ways to handle errors in the language, right?
Will the program still crash?
Yeah, this program will stop if you pass in 0. Sorry, if the array length is 0 in this case.
So what's the point of throwing the exception?
Oh no, sorry. So you're asking, will the program crash if I don't do the check?
Yeah.
That's what you're asking for, right? In this case, it'll crash there when you access the element, but it'll crash at run. It'll crash here. Oops, sorry, back. It will crash when you try to access the element there. Yeah, so it will crash anyway. You'll get a different type of exception though. If that's important to you, right? Now the rest of the code is the same, except here, right? You just loop over the length of the array. How long is the array? Well, the array knows how big it is, right? So it's arr.length, right? Everything else is the same, right? So loops in Java, same as loops in C, except you get a different kind of for loop in Java as well, right? So in Java, there's another type of loop called a for each loop, right? You can use a for each loop with an array. You can't use it with a string, so don't try to do this with a string, right? Which is unfortunate, right? But you can't do it with a string, and you can do it with other things in the language. So we're going to look at lists and other types of collections later on, right? These all are, for all of these types, you can write a for each loop, right? So if you want to look at every element in an array, right, you can use this style of loop, right? So it's still for, right? Now you want to make a local variable, right? The variable refers to the element that you are accessing in this array iteration. You can call it whatever you want, right? So I'm going to call it E here, short for element, right? You need the type of the element. So this is an array of double, so the type of E is going to be double, right? And then it's a colon, and then it's the name of the thing that you want to loop over, right? So I want to loop over the array ARR. And so the way you read this is for each double element E in the array ARR, right? Now inside the loop, you can use E to refer to the element that's in the array, right? So if element E is greater than high, then I know that high is now equal to the element E, right? So there's also a for each loop in Java, which simplifies your life a little bit, right? It's useful when you want to do something with every element in the array, right? Oh, you guys don't, you all know how to write a for loop, right? I don't have to do this, right? Okay. Boom, boom, boom. Does anybody want me to review this? Anybody? No? Okay, good. So I'm just going to skip over this, right? What is sorted? Do I want to do is sorted? Oh, right. There is a point here. Okay, so once you start using the for each loop, it's nicer to use than the counting style loop, right? The C style counting loop. So it's shorter to write. It's easier to read the code inside the loop body, right? Because you don't have to access the array element every time. It has a name already, right? So you're going to want to use it all the time. Now the problem is that with the for each loop, you can only access one element at a time, right? And it's very common when you're writing a loop that you want to access more than one element of the array at a time. So if I want to test is an array sorted, right? I want to look at 2 adjacent elements of the array in each loop iteration, right? I want to look at the first element and the second element and see if they're in the correct order, right? I want to look at the second element and third element and see if they're in the correct order, right? And so on and so on and so forth. So now I'm accessing 2 elements at the same time. I can't use a for each loop. You have to use the C-style counting loop, right? So in this case, I'm going to start at index 1, right? I'm going to go up to, but not including the length of the array, right? And I'm going to look at the element in front of index I, so that's I minus 1, right? And then I want to look at the element at index I, right? If the previous element is bigger than the next element, then I know that the array is not sorted in ascending order, right? And so I can set is sorted to false, right? And then at the end of this loop, is sorted will be the correct value, right? True if it's sorted in ascending order, false if it's not, right? You could just return false immediately right here as well, right? Which is probably the way you should do it. This is a picture of it, of showing you that loop in action, right? I think you all understand how this works. Oh, break. Java has break statements as well, just like in C, right? So if you wanted to break out of this loop when you realize that it's false, you can do that too, right? It also has continue if they told you what continue means, right? What else is here? Oh, this is reverse. So this is another example of when you might have to access more than one element at the same time in the loop body, right? Again, you can't use a for each loop in this case, right? You have to use a counting style loop. So if I want to reverse an array, you just swap the first and last element, right? Then you swap the second and second last element, and so on and so on and so on until you switch the middle two elements, right? So in this loop here, right, I need to access two elements at the same time. So one of them is going to be at index I, right? That's the element at the front of the array. The element at the back of the array is going to be index j, right? So the element at the back of the array is at a length minus 1, right? You just count from start counting from I equals 0 as long as I is less than j, right? So in other words, as long as I is actually pointing to an element that's in front of element j, right? Because as soon as you're not, then you've gone past the midway point of the array, right? Simply swap, right? And hopefully you all remember how to swap two elements or two values, right? Create a temporary value, right? To remember one of the two values, right? Set that value on the next line to the other value that you're swapping with, right? And then set the value that you remembered in temp. Sorry, set the next value to the value that you remembered in temp, right? To swap two values in most programming languages, you always need a temporary variable, right? Oh, and then of course, don't forget decrement j at the end of this loop, right? Because j is counting from the back of the array. Right? Again, this is just a picture of showing it in action, right? So I and j, they're just going to come together until they meet in the middle, whoop, 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 like that. Okay, so I don't know if they showed you this in C either, but the Java for loop works exactly the same as the C for loop. If you want to, you can use more than one loop variable, right? But just like in C, the loop variable, they must have the same type, right? So here, instead of declaring j outside of the loop, right, I can declare I and j at the same time in the first part of the loop, right? So I can set I to 0, I can declare and set j to be length minus 1, right? Similarly, at the end, right, in the update part, you can update both variables as well, right? So I can increment I upwards and I can decrement j downwards, right, at the same time, right? This would be the preferred way to write this loop, right? Which one's this one? Oh, there's another example, right? So again, the for each loop is really nice to use, but if you're iterating over more than one array, you can't use it. Right? You can only iterate over one array at a time. So if I want to add the elements in A to the elements in B, so imagine A and B are vectors, and I'd like to compute the vector sum, right? And I'd like to return the array, right? So in Java, you can return an array, right? You can't in C, right? In C, you always end up returning a pointer, right? But in Java, you can return an array. So the sum of A and B, if A and B are two arrays of int, is going to be another array of int, right? It's straightforward. Right? You just make another array of int, right, using new, right? Of course, if the length of A and the length of B are different, you can't actually sum the two arrays. Well, I guess you could, but you have to decide on how the sum is defined, right? So if they're different, I'm going to say that's a problem. I can't sum those two arrays, and I'm going to throw an exception, right? Otherwise, you just make a new array that has the same length of A or B, right? Write a loop and sum the values inside the loop. Right? So the element I at C is just equal to element I of A plus element I of B, right? And then return C. You don't have to worry about whether or not this is a local array, right? In Java, it's always equivalent to a dynamically allocated array in C, right? You don't have to worry about freeing it. You don't have to worry about doing anything unusual to indicate that this is in fact a dynamically allocated array, right? The Java virtual machine will take care of cleaning up the array for you when you're done with it, right? And so after you call this function method, sorry, the user can return can use the returned array however they want, right? Oh, slicing. So C doesn't have slicing, but if you use Python at all, you might know that you can slice a Python sequence, which is kind of cool. So a slice for an array would be a subarray, right? So if I wanted, say, the middle 3 elements of an array, that would be a slice of an array, right? So in Python, Python doesn't have arrays, but they have lists, which look a lot like arrays, right? So there's a list of length 6, right? If I want the 2, 3, and 4. So if I want the elements 12, 13, and 14, right? In Python, I can write t square bracket 2:5, right? The 2:5 means all the elements starting at index 2 up to, but not including the element at index 5, right? So elements at index 2, 3, and 4, right? And that will return, in Python, it returns a new list containing the elements, that element there, and that element there, right? Which is often very handy, right? If you use MATLAB at all, MATLAB also has a slice, right? You can extract part of a matrix or an array, right? So Java, you can't do this, right? Can't do it in C either. But you can easily, you can write your own slice method, right? So if I'd like to slice this array, right, starting there and stopping at that index -1, right? So I want to be consistent with the way Python does it, right? Then you can write the following method, right? So that's the starting index. That's 1 plus the stopping index, right? So it kind of makes sense that the start has to come before the stop, right? If it doesn't, that's a problem, right? So in this case, I'm going to say that's an error, right? You could do something else. I'm going to call it an error, right? Now you simply compute the length of the array equal to the length of the slice, right? The length of the slice is just the stopping index minus the starting index, right? It works this way because the stopping index, remember, is 1 plus the actual stopping index, right? So in this case, it happens to be stop minus start. So that's the length of the slice. So I just make an array equal to that length. And now I copy the elements starting at that index, going up to, but not including that index, into the new array, right? So I is going to be my index into ARR, right? I want it to start at start. I want it to go up to, but not including stop, right? I now want to copy those into SLC, into my slice, right? Now remember the slice, though, its indexing starts at 0, right? Here I'm starting at start. So the correct index in slice is just I minus start, right? And now you can copy the elements of ARR into the slice correctly, right? And then return the slice, right? And that lets you slice an array, which is handy, right? So to call the Java version of slice, well, it's the exact same thing as calling any other method, right? You might have to import the class that includes the method, right? Is this, oh, in this case, it's the method in the same class, so I don't have to import it, right? You just call slice, you pass in an array, right? And you pass in the indexes that define the slice, and away you go. Sorry, I just want to check the time quickly. Okay, so also in Python, you can copy a list, right? And the way you copy a list in Python is you slice the entire list, and that makes a new copy, right? In C, if you want to copy an array, right, you have to allocate memory for the copy, right? You then either have to write a loop or you have to call memcopy if they taught you how to use memcopy, right? If they didn't, then you write the loop and you copy the elements over one at a time by yourself, right? So here in Python, it's particularly easy to copy a list, right? It's just T square bracket, colon in between, right? Looks weird if you're a C programmer, but if you're a Python programmer, C looks even worse, right? So, so T colon gets you a copy. In Java, you could do the same thing if you have a slice method, but you don't have one, right? If you want a slice method, you have to make it yourself, right? If you want to copy an array, though, in Java, a one-dimensional array, right? If you want to copy a one-dimensional array in Java, you can just call clone, right? So you just write the array name, write .clone, and away you go, right? That gives you a copy of the array. right? So again, much easier than in C, right? And now your copy, this truly is an independent copy of, of the array T, right? If you change copy, T doesn't change, right? If you change T, copy doesn't change, right? They're now independent copies. Right? This only works with one-dimensional arrays, though, right? So if you have a multi-dimensional array, clone won't do what you want it to do, right? You can have multi-dimensional arrays. They exist in Java just like they do in C. There are some differences, but the basic ideas are the same. All right, any questions about arrays? So if you can use a C array, you can use a Java array. You just have to get used to the slight change in syntax, right? And then you can forget about all the stuff you learned in C about whether or not you have to dynamically allocate or not dynamically allocate, whether you have to free, and so on and so on and so forth, right? Any questions? Super, that's all I'm going to do for today. I guess we're done for the week unless you have a lab tomorrow, and I'll see you tomorrow if that's the case.